So, ladies and gentlemen, there's a couple things when we're looking into doing division. All right. The main important thing that we want to do is look at our, first thing we want to do is look at our divisor. And remember, guys, when we look at our divisor, remember we talked about divisors, if they evenly divide, it's called a factor. For instance, if we look at the number 12, we think of the number 6. 6 evenly divides into 12, correct? Yes? So since 6 evenly divides into 12, we call 6 a factor of 12. Everybody agrees? Yes? So if x plus 6 evenly divides into this polynomial, it is called a factor. Okay? So we've got to look at, though, and determine, well, if that's a factor, do you guys remember going back to factory? Let's just assume this is a factor for the moment. Okay? If it's a factor, we know that it has we know that when it divides into there, there's going to be a remainder of 0. But if you guys remember, we already have talked about factors. We've been doing factoring, and we solved by factoring, and we got factors. If you're given a factor, how can you figure out what the zeros are? If let's assume this is a factor, what do we simply need to do to find the 0? Joseph? OK, well, let me just go back to do a review then. If I had x squared minus 3x minus 10 equals 0, right? You go ahead and factor this. Yes? I factored it. I rewrote the trinomial as a product of factors. These are both factors, correct? They're factors. They multiply to give you the product. Then what do you do with the factors to solve? If I want to solve this, what do? I apply the zero product property. So by applying the zero product property, since the product is equal to 0, I can set them both equal to 0. Does that make sense? These are the factors. These are what we call the zeros, or the solutions, or the real intercepts. Yes? Real x-intercepts. Correct? Are we OK? It's a little bit of review. I know it's been a while. So if this is a factor, what would the 0 be? -5. If that's a factor, I know I could set my factor equal to 0 to find the 0. And all I want you guys to understand is when you're doing synthetic division, we don't want to use our factor as our divisor. We're going to be using the 0. So all you're simply going to do is take your factor and set it equal to 0. So whatever your divisor is, you're going to set it equal to 0. Now the important thing is we only can use synthetic division when our divisor is linear, meaning that it's raised to the first power. So if it's not raised to the first power, you're going to have more than one 0, right? For instance, if this was like x squared, would you guys agree with me? Now I'm going to do square root. I'm going to have plus or minus, right? So I'm going to have more than one factor, or more than one 0, which I can't do. I can only do it when my variable is raised to the first power. All right, so then by doing that, I have x equals -5. That is my 0. OK? So when using long division, that's what you're going to do. You're going to use your 0. So you take the 0, Frank, and you put it on the outside. And then you just kind of draw this nice little box. Then what you do is you take the coefficients of each and every one of your terms, including the constants. And just remember, if you are missing a term, for instance, like there's no x squared, then put a 0 in place of that. But you want to make sure that you have this in standard form, going all the way down to descending order. OK? So whatever the degree is, going all the way down to 0. Then you just take the coefficients of each one. So I'll take 2, 7, -11, 21, and 5. So I'm kind of doing this slow again for you, but it's just, I know it's been a while. Then all you guys do is you bring down the first term. 2, 2, 2, 2, 2, 2, 2, 2. Freebie. Then you multiply on the diagonal. 2 times -5 is -10. Then you add on the vertical. 7 plus -10 is -3. Then you multiply on the diagonal. -3 times -5 is positive 15. Add on the vertical. Negative 11 plus 15 is 4. Multiply on the vertical, on the diagonal. 4 times negative 5 is negative 20. Add on the vertical. 21 minus 20 is 1. 1 times multiply on the vertical. 1 times negative 5 is negative 5. 5 plus negative 5 is 0. So that's your answer. But guys, remember when we talked about factors, if we know 6 is a factor of 12, that means 6 divides into 12. Well, how many times, Julian? How many times does 6 divide into 12? 2. That was the answer, right? So we can see that x plus 5 divides into this polynomial with the remainder of 0. So we know it evenly divides. But do we just list the numbers? No, these aren't like this list isn't the numbers. It goes in there a polynomial number of times. So therefore, what we do is this represents the remainder, constant, linear, quadratic, and cubic. OK? Yes? I'd have to take a look here. So the quotient for this problem is 2x cubed minus 3x squared plus 4x plus 1. Does that make sense? Or does that agree with it? And let me just go through one more thing. We know 6 divides into 12 2 times. Do you guys agree with me? 2 times 6 equals 12. Right? Does that make sense? So if I'm saying that x plus 5 divides into this many times, correct? Would it then be OK to say x plus 5 times 2x cubed minus 3x squared plus 4x plus 1 equals my polynomial? Why not, right? Does that make sense? Now, if I could have everybody's really, really close attention, because this is really something that I want to hit on. That's really, really important, Santana. Really, really important if everybody could focus here. Everybody seems to have no problem with division with numbers. 6 divides into 12 2 times. 2 times 6 equals 12. Correct? X plus 5 divides into this 2x cubed minus 3x squared plus 4x plus 1 times. This times that equals your polynomial, right? Now, let's just go back through again something. What is the process of taking a polynomial and rewriting it as a product? What is the process of taking a polynomial and rewriting it as a product? I already did a problem to start this off. What do we call a process of taking a polynomial and rewriting it as a product? Factoring, right? So when you write a polynomial as a product of 2 factors, that's called factoring, right? X, what was this, minus 5, x plus 2? That's factoring. Now, have I taken this polynomial and rewritten it as a product of 2 factors? Yes, I have, right? So guess what? These are what? Factors. So if I wanted, I'm getting ahead of myself, but I want you guys to make the connection, Marielle, if you guys could really pay attention to this. If you guys are looking at this, when I have the product of my 2 factors, since these are factors, if I was asking you guys to find all of the zeros, right, find all of the x-intercepts, first of all, how many zeros, solutions, x-intercepts do I have in this problem? How many am I going to have? Huh? How many do I have? Yeah, 4. Yeah. So, but what I just want to show you guys is I could set this equal to 0, right? Then is it possible for me to go ahead and solve the remainder of solve each of these? Possible. We'll get through more techniques. But I want you guys to understand is now I can set these both equal to 0 and solve. Do we already know what 1, 0 is? -5, right? Then what we'll learn later is how to find the rest of the zeros from this polynomial. Okay? But we will go over some techniques for that. But I just want you guys to understand is once you get the quotient is also a factor. It's just not an answer. It's also a factor. So if you are asked, hint, hint, if you are asked to find all of the zeros, when you do synthetic division and you get a quotient, that's a factor. You can set your factor equal to 0 and solve for more factors and more zeros. Hint, hint. OK? Now, what I'd like you guys to do, wow, that was a long